Welcome to video 2.2 in probability. We're going to use the multiplication rule in license plates. So here's example 2. Suppose a standard license plate in Illinois has 3 digits followed by 4 letters. There's 3 questions. A, how many different license plates are possible with repetition allowed? In other words, it could be like 555, A, B, B's, anything like that. All right, so I'm a visual person. I like to put slots for possibilities. So for my digits, I've got 3 possibilities. And for my letters, I've got 4 possibilities. My digits can be any digit. It could be 0 through 9, 0 through 9, 0 through 9. So I just start. How many ways of filling in the first digit? 10. The second digit? 10. The third digit? 10 different ways. And I'm going to multiply the number of ways of doing one event times the other event times the other event times some more events to come, the letters. Letters can be A through Z. We won't worry about uppercase versus lowercase. We'll assume they're all uppercase. All right, so it could be A through Z, A through Z, A through Z, and A through Z. Again, I put my restrictions at the bottom, or the possibilities, and there's 26 ways of doing this, 26 ways of doing this, 26 ways of doing that, and 26 ways of doing that. So I'd multiply it all together. I'll give the computation at the end, but I'm more concerned with the setup of the problem than just pressing buttons on a calculator. All right, part B is the exact same as part A. However, in this case, there's no repetition. So I can only use a digit once or a letter once. All right, so again, I'll set up my 3 possible digits, my 3 possible letters. Again, I've got the same possibilities below. So as far as this first digit, there's 10 ways of performing that step. However, once I pick a digit, I don't care what digit it is, 1 or 0 or 3, I can't use it again. So whatever digit I chose there, do not choose again. So over here, I could be any 10 digits except for that one, which makes 9. Same thing applies here. Be any of the 10 digits, just don't be that one or that one, which results in just 8. Okay, same kind of thing with the letters. For the first letter, be any of the 26 letters in the alphabet. Then for the next letter, be any letter except for whichever one that was. And so on and so on. Again, I'm more concerned right now with the setup rather than the punching out the buttons. I'll do that at the end. All right, part C, this is the more challenging one. Same problem, no repetition allowed, so kind of like this one, but there's some more constraints. The first digit must be even, and the last 2 letters must be G-O in that order. So not O-G, just the last 2 letters are G followed by O. Okay. I'm going to do the same thing, write down the slots. So 1, 2, 3 for my digits. 1, 2, 3, 4 for my letters. All right, and there's a very, very important concept. Note, in general, always perform the most restrictive step first. Just get that out of the way, and then it's much easier to deal with the other steps. So in this problem, let's see what's restrictive. The first digit must be even. So as far as the digits are concerned, that's going to be very constraining. So let's do that step first. Okay, so I'm going to do this one first, just to let you know. It also happens to be the first digit. That's just a coincidence. So the first digit must be even. So what I'm going to do is just list my possibilities below. So we need to know what the even digits are. 0 is an even number. Okay, so I could be 0, 2, 4, 6, or 8. Okay, So how many ways are there to perform that step? 1, 2, 3, 4, 5. Again, I'm not saying that I'm choosing a digit 5. I'm saying there's 5 ways of picking one of those digits. Okay, so one of those digits has been picked. I don't know which one, but one of them has. Over here, I've got no constraints here. I could be any of the 10 digits. However, they did say no repetition, so just don't be whichever even digit you selected. All right, so out of the 10, don't be that one, so there's 9. So it's very important that we did this one first so we have a clearer path for the rest of the problem. Over here, be any of the 10 digits that you want, just not this one and just not that one. So I'm back to 8. Okay, now I'm going to come over here with the letters. Again, let's do the most restrictive steps first. Well, I've got some restrictions here. The last 2 letters must be G followed by O. All right, so again, below I put like my possibilities. So you could only be G and you could only be O. Hey, those are my initials as well. All right, so how many ways to do that step? 1. How many ways to do that step? 1. So notice I did this first, then I did these I did those, and then I did that first on the letter side, if you will. Then I'm going to go back and do these earlier letters. Okay, so again, don't always go from left to right. All right, so this could be any letter in the whole wide world, just not G and just not O. How many ways to do that? 24. Because it was 26, take away 2. How about this one? Be any of the 26 letters, although don't be G, don't be O, and don't be the one you selected over there. 26 take away 3 is 23. And then I would just multiply all of those out. All right, so just for the final answers, I got for this first one, 4, 5, 6, comma, 9, 7, 6, comma, 000. For this one, I got 2, 5, 8, comma, 3, 3, 6, 000. And for this one, I got 1, 9, 8, 7, 2, 0. So you can see the more restrictions you have, the fewer possible ways there are to do it. And that makes total sense. So there you have it. How to use the multiplication rule to solve some license plate problems.